Welcome class to the last video of the school year, your exam review. There's quite a bit to cover here, but I'll do so as quickly as possible. The structure of your exam will be organized according to the four components of assessment, which is knowledge, application, thinking, and communication. But for the exam review, I'm just going to go over it unit by unit. So the first unit is geometry, and you should study composite perimeter. And just a couple points to keep in mind when you're doing that. If you were given a shape that was something like this, and you saw that you had lines like this, and it told you this side was 4 meters, well then you would know that this other line over here has also a measurement of 4 meters. If you saw that it had two lines like this, there and there, then you would, and it told you that this was 10 meters, then you would know this other one was also 10 meters. So we would have these measurements here. Okay, and once they did that, you would be able to figure out the lengths of the missing sides. So we have the lengths of two missing sides here, here, and here. And to find this line here, you would simply do 10 minus 4 equals 6 meters. And we know that because this whole side here from here to here is 10. This part here is 4. So to find this missing section, here, you would do 10 minus 4. And to do this line, this missing line here, you would do the same thing. You know that, again, this whole side here, because of this top side, you know that the whole side down here is 10 meters. And so you could put 10 here at the end. Then you have this missing bit here, and you know this part here is 4. So to find this line here, you would do 10 minus 4, and you would also get 6 meters. So we know this is 6 meters, and we know the other line that was missing is also 6 meters. So now to solve composite perimeter question, all you have to do is add up all the sides. P equals 10 plus 4 plus 6 plus 6 plus 4 plus 10. Okay, and then you would do 10 plus 4 is 14, plus 6 is 20, plus another 6 is 26, plus 4 is 30, and you would get 40 meters. Now, one other thing is, if I wanted to show that the two unknown sides were also equal, and I wanted to use those lines like I did for the other equal lines, I would do 3, so that they wouldn't be confused with the other ones. Alright, so that's composite perimeter. We'll do one for composite area now. Alright, so for composite area, and you can see this in your review handouts as well, the first thing I want to do is see if there's any unknown sides. Now this is a rectangle, so I know that this side over here is going to be 15 centimeters, and I know this is going to be 25 centimeters. It's not all that relevant for us, but we can write those out just to follow the step. And then after that, I want to label the area. So this is going to be my area 1. This is going to be my area 2. I've divided my shape up into two separate areas in this case, area 1 and area 2. And this question here, if you get this kind of question, it's asking for what is the area of the shaded area. What's the shaded area? Okay, you can imagine all that stuff is shaded. And so then if I'm trying to find the total shaded area, then what I need to do is I'm going to need to get the area of A1 and then get the area of A2, and I'm going to need to subtract A2 from A1. So I would write my total area my shaded area equation would be shaded area equals A1 minus A2. Okay, and so then I would need to figure out A1. A1 equals length times width. A1 equals 25 times 15. and that equals 375 centimeters squared. Then I would need to figure out A2. A2 is base times height divided by 2, and the base is 5, and the height is 4, so I'm substituting here. Then I divide by 2, it's 20 divided by 2, and 20 divided by 2 equals 10 centimeters squared. Then I would just take the areas from those two, plug it into my shaded area equation, and I would get 375 minus 10 equals 365 centimeters squared. And that would be my final answer. Okay, so that's composite area and a shaded area question. Okay, another kind of question you should be prepared for is calculating volume, and you will be permitted to have your formula sheet, so you won't have to have the formulas memorized or anything. But let's say you got this shape, you would recognize that it's a cylinder, and you would then write the cylinder formula for volume. This question is obviously asking you for volume, and you would write pi r squared times height, and then you would do pi, and then the radius is 10, so you would do 10 bracket squared height times 36.4. Okay, then you would always do your square first, so you do pi 10 squared equals 100 times 36.4, and then you would simply do the multiplication, and you would end up with 11,435.39726, but we can round it to one decimal place, and we would get 11,435.4 centimeters cubed. Okay, still in the geometry unit, the other thing we worked on in geometry was the Pythagorean theorem. So if we were given a triangle like this one here, and you were given this measurement and this measurement is 3 meters and this is 4 meters. In this case, because we're trying to find c, the form of Pythagorean theorem we're going to use is going to be c squared equals a squared plus b squared. And then we would write c squared equals 3 squared plus 4 squared. And then, because we substituted in 3 for a and 4 for b, and then 3 squared, we have to square 3 now, we get 9. And 4 squared, we get 16. And we write there our next line, c squared equals 25. And then we have to square root both sides. So if we square root c squared, we get c. And now we have to square root 25, and that would mean c equals 5. Okay, now another version of the same question, or kind of question, is if you are given a leg, or you need to find a leg rather than finding the hypotenuse. So we'll do that on the next page. Okay, so this question is still requiring us to use the Pythagorean theorem, but this time we're trying to find a leg. So when we're doing this version of the Pythagorean theorem, we're going to do x squared, it could be a squared, doesn't matter what the variable is, and now we're going to have to do c squared minus b squared or a squared or whatever you want to label it. But the key point here is that the hypotenuse is going to be first, and you're going to subtract the known leg from it. Okay, so then here I would do x squared equals 5 squared minus 3 squared. X squared equals, and I square 5 and I get 25, and I square 3 and I get 9, and then I would get x squared equals 16. I have to square root both sides, and I end up with x equals 4. So in the next unit I'm looking at is optimization, and so this is about making the rectangle with the largest area for a given perimeter or making the rectangle with the minimum perimeter for a given area. So if you need to be able to read and analyze these kinds of questions so that you know what the question is asking you for, and you can therefore solve it. So in this question, we have Jacob is making a rectangular playground with 200 meters of fencing. What is the largest playground he can make? What are the playground's dimensions? So there's two questions there. And if I'm using cubes as you've been taught to do, then I'm going to circle my number. And I'm going to underline my question. What is the largest playground he can make? And what are the playground's dimensions? I'm going to put squares around my keywords. Keyword here is fencing. Keyword here is dimensions. Okay, and keyword here is largest. Okay, so you've been taught when working with this kind of question to use acronyms. So in this case, because it's talking about fencing, I'm looking for perimeter. Or I've been given perimeter, I should say, and I'm trying to find the largest area. So in this case, I use the acronym PSA. And the given perimeter in this case is 200 meters. And if I want to find the side of one of the sides of the rectangle I'm going to create, I'm going to have to divide it by 4. And 200 divided by 4 gives me 50. And that means my side equals 50 meters. Okay, so that was my P, was I put the 200 in, I divide it by 4. My side now equals 50. Now to find the area, if you recall, the formula for the area of a square is s squared. So I would do 50, and I would get as an answer 2,500 meters squared. And so to do this question, you can see I got my given perimeter, and I simply divided by 4. And then I got my side, and then I plugged in the area formula. So the second part of this question asks you for the dimensions of the playground. So it's a square, so if one side is 50, the other sides are all going to be 50, and the dimensions are therefore going to be 50 times 50, or 50 by 50. 50 representing the length on the left, 50 representing the width on the right, 50 by 50. Alright, so this question is, Erica has been given an area of 100 meters squared to put a large rectangular garden. She wants to save money on fencing. What is the least amount of fencing she can use for her rectangular garden with an area of 100 meters squared? What are its dimensions? So again, I'm going to use cubes. I'm going to circle the numbers. I'm going to underline the questions. What is the least amount of fencing she can use for her rectangular garden with an area of 100 meters squares? What are its dimensions? And I'm going to put squares around the key words. Okay, so given area of 100 meters squared, right? And she wants to save money on fencing, so we're going to be finding a perimeter, least amount of fencing. Again, we're finding perimeter, and we want the dimensions. So we're given the area, and we want to find the perimeter, so we then use the other acronym we learned, which is ASP. So we get the area was 100, and in this case, to find the side length, we have to square root 100. So the square root of 100 equals 10, so that means that the side is going to be 10. And then I plug it into the perimeter formula. The perimeter formula for a square is 4s. So then I can just do 4 times 10, and I get 40 meters. That's my answer for the first question there. The least amount of fencing that I will need will be 40 meters. The second question is, what are its dimensions? Well, remember again that we're working with a square, and so the dimensions are going to be 10, because that's one side, by 10. Alright, so we're just going to skip over Unit 3 here for now and move on to Unit 4. We'll come back to Unit 3 when we're doing all of the units that pertain to graphing. So Unit 3 is all about proportional reasoning, and as you've been taught, when you're reading questions related to proportional reasoning or any kind of word problem, you should be using cubes. So the question is, 5 chocolate bars are selling for $2.25. How much is each chocolate bar? So I'm going to circle my numbers. I'm going to underline my question. And I'm going to box this keyword here, each. Okay, and I'm also going to box here much. And this much is talking about how much does it cost. And each is telling me that I'm trying to find a unit rate. Okay, so to do this question, first what I'm going to do is I'm going to create a fraction. And my fraction is going to be $2.25 divided by 5, and it's going to be that because I'm trying to find out how much each bar costs, each chocolate bar. So I always put the measurement or unit that I'm trying to reduce to 1 in the denominator of the fraction. This is the denominator here. 5 is the denominator here. Okay, so I do $2.25 divided by 5, because fraction is division, and I end up getting $2.25 divided by 5. I get 45 cents per chocolate bar. Okay, then I want to answer question B. Again, I'm going to use cubes. Janet wants to purchase 20 chocolate bars. How much will it cost her? Underline my question. It's asking about total cost. And so the simplest way to do question B is I can see that it cost me 45 cents per chocolate bar, and I want 20, so I'm just going to do 0.45 times 20, and that's going to give me the answer of $9, and that's the answer for B. Okay, another kind of question you could get is like this. A punch recipe calls for a combination of Sprite and cranberry juice at a ratio of 2 to 3. How many liters of Sprite should I add to 15 liters of cranberry juice? Okay, so again, we want to use cubes. So I'm going to circle my ratio here, which is 2 to 3. I'm going to circle 15 liters. I'm going to underline my question, how many liters of Sprite should I add to cranberry juice? And I'm going to square, it's asking me how many liters am I going to add to 15 liters of cranberry juice. Okay, and I should also note here that it's going to be Sprite and cranberry juice because the order of the question, it's worded as Sprite and cranberry juice. That means that Sprite is going to be the first term in my ratio, and cranberry is going to be the second term in my ratio. I could write it like this, so Sprite to cranberry. Okay, and I can recognize that it's going to be 2 is going to be Sprite and 3 is going to be cranberry. Okay, so I should write this out then. 2 to 3, we got Sprite, we got cranberry, equals, and says how many liters of Sprite should I add to 15 liters of cranberry. So I'm going to write my ratio here. Again, it's going to be Sprite to cranberry, and it told me 15 liters of cranberry juice. Okay, so I can solve this. You've learned 2 ways to do this, and we'll use the cross multiply and divide. So I would get 2 over 3 equals x over 15. And to do this, then I would do cross multiply here, 2 and 15, and I would get 2 times 15 equals 30. And now I'm going to divide 30 by the remaining number here, 3. So 30 divided by 3 equals 10. And so the answer is 10 liters of Sprite. So another kind of question you can get related to proportional reasoning will involve, you want to purchase something, there's a sale, and there's some tax. So let's read the question first. A t-shirt costs $12.99. It is on sale for 20% off. The sales tax is 13%. I'm going to use cubes. I'm going to circle my numbers. I'm going to change my percentages to standard form. And then I'm going to underline my questions. And my keywords are going to be these parts here, because that's what I'm trying to find in each one of them. So let's label them A, B, and C, and we'll work our way through them. So if I want to find the discount on the shirt, $12.99 times 0.2, and I end up getting $2 or 2.598. Okay, so we could round that to $2.60. Okay, then for B, it's asking me the sales price. Well, I can just take the original price and subtract the $2.60, and I would end up with $10.39. So that answer is B for my sales price. Then what's the sales tax going to be? I have to now take my $10.39, because that's my new price after the discount, and I'm going to multiply that by 0.13, and I get $1.35. And then for D, I'm going to do get my total price, so I have to take my $10.39 and I need to add my $1.35, and that gives me a total of $11.74, and I've answered all 4 of those questions. So in this section of the video, I'm going to look at chapters 3, 5, and 6 all together, exploring relationships, linear equations, and multiple representations. So a kind of question you could get involving a scatter plot would be like the one you see here on the left. The graph shows the shoe size of girls of various heights. Which point represents a girl whose shoe size is smaller than expected for a girl of her height? And so you can see that the x-axis down here at the bottom is giving you their height, and over here it's giving you their shoe size, and you can see the trend of the data here is positive, and it's a strong correlation. Okay, and so that's how you would describe if we were asked for the trend or the correlation. It's positive because it's going from up from left to right, and you can kind of make a straight line there, so it's linear, and it's a pretty strong correlation. So if we were to answer this question, which point represents a girl whose shoe size is smaller, that would be our key word here, smaller than expected for a girl of her height. So if we look at the data, we can see there's a couple of points that stick out. There's this X point, and there's this Y, and this Y point. This person who is represented by point X is somewhere between 165 and 170 centimeters tall, but her shoe size is about 6 or 6.5. And you can see that's outside of the data. So it doesn't fit with the trend. This Y person over here, they're somewhere between 155 and 160, and their shoe size is 11. And that's a pretty big shoe size for someone who's not that tall and fits outside of the data. And so if we look back at X, we can see that X actually has a small shoe size comparative to her height, especially if you compare it to these other data points right here. And so our answer for this question would be X. And so it's important to be able to recognize when you have these what are called outliers, pieces of data that don't fit with the rest of the trend, and you should be able to interpret them the way I just did. So another kind of question you might get is one that involves a distance and time graph. And so you need to be able to interpret all parts of the graph. And I've put this question here, but really I'm just going to interpret the graph for you. And so the bottom axis is always representing, the x-axis is always representing time, the y is representing distance from home. And so if I was to describe this line here as A, and I wanted to say what happened with A, then I could say for A, Oscar rode at a constant rate of speed, constant rate, so constant rate, and I could figure out what that constant rate is by using rise over run. So the rise we're going from this point to this point over here, the rise is going to be 2.5. So rise over run, so I get 2.5 divided by the run, which was from here to here, that's 10. 2.5 over 10, that equals 0.25. And what this means is that his speed was 0.25 kilometers per minute. And the other point that I would want to make about A is that his direction was away from home. Okay. Then I could interpret this next line here, B. And B, we can see if remember, y-axis measuring the distance from home, B, the distance from home hasn't changed from the point 10 2.5 to 25 2.5. Okay, and so what that means is for 15 minutes, Oscar did not move away from who he stopped. He stopped at the beach. Okay, so I would just write in here, if I'm interpreting B, stopped moving, right? And we know he's at the beach. And let's imagine I'm interpreting now line C. Now I'm going to be comparing this point again here to this point down here. And if I want to describe what he's doing for C, now he's going to ride back towards home, right? So riding back towards home. And constant rate. And what's his rate? Well, rise over run again. And so the rise here is going to be from here down to here. So that again is 2.5 kilometers. And this time it took him 15 minutes. So the run from 25 to 40 is 15 minutes. So 2.5 divided by 15, his rate of speed this time was 0.166, and 66 it goes on, okay, and that is 0.166 kilometers per minute. Okay, so when I'm interpreting a distance time graph like this, I'm getting the direction, I'm getting the rate of speed, I'm getting if it was constant, okay, or not constant. It would be curved if it's not constant rate. Okay, so another kind of question you might get is you were given some kind of pattern and you need to figure out the algebraic pattern or algebraic equation to represent that pattern. You would also have to find a table of values and figure out the rate of change. So if I were doing, though, a table of values for this, then I would have here on my left the x variable, the independent variable, which is the term, and then over here I would have my y variable, or the dependent variable, that's the number of sticks. Okay, and so for term 1 I have 2 sticks, for term 2 I have 5 sticks, for term 3 I have 8 sticks, and for term 4 I have 11 sticks. And so if I wanted to find the rate of change, I could just find the first differences and I would see that they all equal 3. Therefore the rate of change is 3. Now if it asked me for the algebraic pattern, what it's asking me for is the equation. And so I could do n for the number of sticks equals, now I know the rate of change, so I can do 3 times the term. However, what I need to now find is what is going to be the initial value. Remember, the initial value is the value of y when x equals 0. So it's like I'm imagining there's the 0 up here. What's the value of y going to be if x equals 0? Well, remember the pattern is going up by 3. So if the pattern's going up by 3, I'd have to go 3 down from 2. That would give me -1. And that would tell me the y-intercept is is -1. And the equation, therefore, is 3t minus 1. Now, what if it said if you were at term 20, how many sticks would you have? Term 20, how many sticks would you have? Well, then you just need to plug 20 into the equation. N equals 3 times 20 minus 1 equals 60 minus 1 equals 59. You'd have 59 sticks at that point. Okay, so this is just finding a pattern, and then using the pattern to find the equation, and using the pattern to find the rate of change, and then we use basic substitution when we were given the term and we need to know the number of sticks. So another kind of question you can get on the exam is where you're given a word problem or a verbal model and you have to create an equation based on it. So again, we would use cubes. So here I would circle 150, I would circle $2. It's asking me to create an equation for going to the movies for 1 year. If I'm going to bold some, this is an annual VIP membership, and it's for 1 year. And I'm going to do per movie because that tells me that this is the rate of change. And I'm going to know based on that this is the y-intercept. 150 is that initial fee, so it's the y-intercept. So if I'm going to create an equation, then my equation would simply be cost equals $2 times the number of times I go to the movie plus 150. Okay, so that's my equation. If I wanted to create a table of values, so create a table of values. Then simply put here and here, this is number of movies that I go to see. And this here is cost, measured in dollars. Okay, so let's say I went to 0 movies, but I bought the VIP membership. It's going to cost me $150. Doesn't sound like a very smart idea to not go to any movies if you buy the membership. If I go to 10 movies, it's going to cost me $170 because it's $2 per movie, so that's 20. Add it to the 150 that I had, I get 170. 20 going to equal 190. 30 is going to equal 210. And 40 is going to equal 230. Okay, so that's my my table of values. Now, what if they wanted to know the rate of change? Well, it's easy to find the rate of change just based on my equation and the verbal model. It's $2 per movie, so the rate of change equals $2, right? Which represents $2 per movie. Something else they might ask you is this direct or partial variation? Well, because there's a y-intercept that's not 0, the y-intercept is not 0, the graph will not go through the origin, therefore this is an example of partial variation. Why? Because the line or graph does not go through the origin. You should also be comfortable graphing this kind of equation. I would direct you to your notes in the unit reviews that show you how to graph an equation, that go over the rules for doing that. Okay, so you might see a question like this on the exam. You get a graph, there's two lines on it that intersect. So if we look at this graph, we see total monthly cost versus number of games rented. We see the y-axis is measuring the total monthly cost. We see the x-axis is measuring number of games rented. And so you might get a question that asks you about the point of intersection. So if we're looking at the point of intersection, we could find that very easily. Where do they meet? Well, they meet here at 6 and 30. And they might ask, what does 6 and 30 mean? Well, it means to rent 6 games, it costs $30 at both stores. Okay, then they might ask you which one's the better deal. And if you're asked that, the question's always three parts, because it really depends on the number of games you rent. So if you rent less than 6 games, then you can see on the graph here that Mighty Gamers is cheaper than Sir Game-A-Lot when you rent less than 6 games. So you would say, if you rent less than 6 games, Mighty Gamers is cheaper but if you rent more than 6 games, well, you can see here that Sir Game-A-Lot is cheaper. So when you rent more than 6 games, Sir Game-A-Lot is cheaper. And then you would also mention they cost the same for 6 rentals. And that's how you answer that kind of question. So moving on to the next unit, algebraic models. So you learned how to solve 1- and 2-step equations. Just quick review of a 1-step equation here. If we have x plus 15 equals 20, well, it's a 1-step equation. We need to isolate x. We need to subtract 15. If we subtract 15 from the left, we got to subtract from the right. So I can simply write in my next line x equals 20 minus 15, because 15 minus 15 equals 0, so I don't need to write anything on the left side there except for the x, and I get x equals 20 minus 15, x therefore equals 5. And if we had a 2-step equation, and we'll mix this up and we'll throw some distributive property in there as well. Let's say I had a question like this: 2 times bracket 4 plus 6w equals 17w minus 12. Okay, so again, this time you have variables on both sides. You're going to try to get all the variables to the left or to the right side. So it's up to you. And I'm going to try to get all the variables to the right side for this. But before I can do that, I got to do the distributive property or distributive law. And so I would do 2 times 4 equals 8, 2 times 6w equals 12w, and so I get 8 plus 12w equals 17w minus 12. And so, as I said, I'm going to try and get all the variables on the right-hand side and all the known numbers on the left-hand side. So to do that, I'm going to move this 12, this negative 12, over to the left side. Now moving it, what I'm doing is I'm adding 12 to both sides. So I would write here 8 plus 12 plus 12w equals 17w, and I don't need to write that negative 12 because I added 12, it became 0. then I would have here 20 plus 12w, sorry, this should be 17w, equals 17w. Okay, so now if I want to get all the variables on the right hand side, I'm going to have to subtract 12w from both sides, so I get 20, and I subtracted 12w from that side, so it's 0, so 20 equals 17w minus 12w, and I get 20 equals 5w, and now I need to divide both sides by 5 so I can isolate w, so I divide by 5, and I get 4 equals w. Okay, so that was a little more advanced question that kind of mixed together a few things that you need to know how to do. Distributive law, you need to know how to solve an equation that has variables on both sides, and it involves the things we learned for two-step equations, which is dividing by the coefficients. You can see down here I had 5w, so the 5 is the coefficient. So to isolate w, I got to divide both sides by the coefficient, by both sides by 5. So in these two questions, I was solving, and that's very important, solving. Okay, what does it mean by solving? I'm finding a value for x, or any variable. Okay, so there are other questions that are just going to ask you to simplify, and we'll do those next. So as I mentioned here, we're going to be looking at simplifying. So simplifying means you have an expression, you're working with an expression, not with an equation. That is, there's no equal symbol in it. Okay, so we'll do a pretty easy one to start us off. We have 6x plus 3x squared plus 4x minus 3. So the first thing I'm going to do is I'm going to reorganize it into standard form, which means I got to put my 3x squared first because it has the highest exponent, plus 6x plus 4x minus 3, and then I would combine my like terms, and 6x plus 4x equals 10x. I leave the 3x squared because there's nothing to combine it with. I leave the negative 3 because there's nothing to combine it with, and this would be my answer here. That was a simple example of simplifying. So another example, a little slightly more complicated, would be this example here, 7x squared plus x minus 3 minus bracket 2x squared minus 6x minus 4. Okay, and so in this case I have a subtraction and then I have terms within brackets, and I know when I have that I have to change all of the signs within the brackets to their opposites. So I'm going to rewrite the equation first without the brackets, and I get 7x squared plus x minus 3 minus 2x squared. So notice that the 2x squared, which was positive, now become negative, plus 6x. And again, you should notice that the negative x became positive because I'm changing the sign to its opposite when I take the brackets off, and then I get plus 4. Okay, so once I've written it out like this, then I need to write it in standard form, so I would get 7x squared minus 2x squared, and I'm putting these terms first because they have the highest exponents. Then I would get plus x plus 6x minus 3 plus 4. And we've learned before it's helpful sometimes for us to put boxes around these so we don't forget any of the terms, and we keep the sign with the term when we reorganize it. So let's just make sure I got everything. Did I get my 7x squared? I did. Did I get my plus x? I did. Did I get my negative 3? I did. Did I get my negative 2x squared? I did as well. I got my plus 6x, and I got my plus 4 down here at the end. Okay, so now that I've put them in standard form, now I can combine like terms. 7x squared minus 2x squared equals 5x squared. Plus x plus 6x gives me plus 7x. Negative 3 plus 4 gives me plus 1. And this is my answer. Now, that squared looks a little bit messy. See if I can fix it. That's a bit better. And this would be the simplified expression that I would need at the end. Okay, so last kind of question I'm going to do with you here for this unit maybe even for the whole video here, you get a shape, you're given these values for each side of the shape, and you're asked to simplify an expression for the perimeter of the shape. Okay, so this perimeter, remember perimeter just adding up the sides, so perimeter is going to be 3x plus 2x plus 2 plus 5x plus 2x plus 2. Okay, then I'm going to rewrite this now in standard form, putting my variables at the highest exponents first, and so I can combine them together more easily. I get 3x plus 5x plus 2x plus 2x. So remember, those squares really help us there, and I almost missed one. So I'm going to put my squares just so I don't miss anything and I can check them off after. So I got my 3x, I got my 2x, got my 5x, and I got my 2x. Good, now I have these plus 2's left, so I put plus 2, plus 2. I got those. Now I'm going to combine my term 3x plus 5x is 8x plus 2x is 10x plus 2x is 12x. 2 plus 2 is 4. And this is the simplified expression for the perimeter of this shape. So this video, I'm sure, is quite long by this point. I'm going to actually finish it up here. Plane geometry, I've already made a video for that. It's on the website. You can go and check it out. You also were given a study sheet before the last test for the course. I would highly encourage you to take a look at that. Just very, very briefly, I would make sure that you review the EAT theorem. So that's exterior angle theorem, and that relates to the triangle. It says these two added together, these two interior angles opposite the exterior angle, equal this angle here, right? So if I made this x and I made this square and I made this the circle, then that would mean x plus the square equals the circle, right? So very important for you to remember that. The other thing you want to make sure you remember is the different angles that are created from a transversal and parallel lines. You should know co-interior, alternate, and corresponding. Again, I made a video about it already. Check your study sheet. Make sure you know that stuff. If you made it this far with me in the video, you are pretty much guaranteed success. Good luck writing the exam.